Hello, my name is Niall Brady and I'm a Director of Digitise Consulting. Today I'm going to share with you how Digitise have set up our systems to deliver to the Transport for New South Wales Digital Engineering Framework using 12D, or as per the title of the presentation, finding the simplicity in the complexity. So many people here today may not be familiar with the Transport for New South Wales Digital Engineering Framework. So first off, I'm going to give a very brief introduction on the framework, followed by how we've applied these requirements to the use of snippets, using library of BIM objects, using a custom attribute manipulator file, and then finally extracting this data to generate the asset register at the end of the project. Most of you believe digital engineering is only about the 3D BIM model, which is not correct. It is built up of much more. Once you start adding in time 4D, cost 5D, and asset data 6D, plus adding in other elements including GIS, document management, requirements management, risk management, and other data, we get a full picture of what digital engineering actually is. Digital engineering is described as a collaborative way of working using digital processes to enable more productive methods of planning, designing, constructing, operating, and maintaining all our assets. So back to the framework. So the Transport New South Wales Digital Engineering Framework is made up of many documents, including the DE Standard Part 1, which concentrates on the concept and principles, and Part 2, which concentrates on the requirements. It also has a number of project data schemas, or PDSs for short, and the one we're going to look at today is the BIM schema and specification. So the BIM schema is divided into 3 property sets. So we have transport project, location, and asset. Each of these property sets are made up of multiple attributes that must be added to the BIM model as metadata. We have 12 project, 11 location, and 23 asset attributes. These attributes are used to classify objects within the model using Unit Class 2015, supplemented by existing Transport for New South Wales asset data to support project handover. Here's an example of the location classification in the BIM schema. Here you can see each road name, carriageway, lane, etc. has a project location code and a corresponding unit class classification code for complex, entity, and space location. Next up, we have the asset classification. This is seen more of a master classification library with codes adopted as needed to suit the project. These include classification for line marking, signs, pavement, drainage, road furniture, structures, utilities, and many, many more. Here you can see each asset in the register has an asset type code, an asset instance, an asset code, and an asset label, which makes it unique within the BIM model. With each of these assets assigned a corresponding unit class code for element or function, system, and product. So when you initially get some of this project information, it can be really overwhelming with the amount of data you receive. What does it all mean? What does all the ones and zeros mean? So let me take you through that right now. So breaking it down, we're going to initially look at the transport project requirements. So these requirements are generally consistent across the same model and is largely based on the model file documentation, including the project name and code, design company name and code, coordinate system, milestone, state and suitability of the document, name and number of the document, and the discipline or sub-discipline associated with the document. And because all these attributes are consistent, we can actually apply these as 12D project attributes within the project. Here's an example of typical project attributes that can be applied. We can then pull these attributes into the MTF and snippet rather than typing this out every time, saving time and effort on the project. Next, we have the location classification. Transport break the location into a hierarchy, assigning a transport location code and corresponding unit class classification code at each level. Here we have a typical road example with the New South Wales Highway assigned as the complex or road network, the main line assigned as the entity or roads, and carriageway B assigned as the space location, and then a second level of space location for all the shoulders and lanes that make up the cross section of the carriageway. So these locations are all presented in the BIM schema for each project. Similar to project attributes, we have all these asset location codes and unit class classification codes all listed within the model. So in this example, I'm going to show you the process for populating this information using a snippet with a few selections. So first up, we're going to set a few master MTF attributes at the top using a snippet. These are common across all assets in the MTF and will save time inputting for each line in the MTF. For this MTF, we're going to enter in the road number, which is ML, and the carriageway type from the drop-down list. So this dual prescribed in this example. So what we're trying to add in here is the first level of entity, so ML mainline, and the first level of space location, which is carriageway B. We can also have other options within here, which would be single carriageway, which would be carriageway A, counter carriageway would be carriageway C, and ramps are STU, etc. These master MTF attributes are then written out as temporary attributes at the top of the MTF and can be pulled into each snippet used within the MTF. For this initial input, we're only applying the two fields for the location, which you only do once within the MTF. Next, we have the asset classification. Again, we have the list of attributes we assign to each asset code and unit class classification. In this example, I'm going to insert a curb snippet to the same MTF, adding in our normal picks for the start and end chainage, but also adding in the asset instance. So this can be a number or a chainage just to help generate the unique asset label. We then also pick our curb type from the dropdown. So in this example, it's an SA curb type. And then the last level of location, the lane number from the pick list. In this example, the prescribed left turn lane 1. So in total, we've only populated 4 attributes for this curb snippet. We would apply the same for pavements, line marking, etc. So once we recalc our MTF, the snippet does all the hard work for us. It applies all the attributes to the MTF objects, including to the correct IFC property set. So for the transport project property set, these attributes are all pulled from the 12D project attributes we set up earlier, so no additional input is required for these fields. Moving on to location. So we have set up these 3 attributes before, including ML for the main line, B for the carriageway, and PL1 for the lane, which is just off the screen here. Here the snippets again assign these to the correct property set and attribute name, but also we can use these codes to populate other attributes within the location, like the location code, description, concatenated together using the snippet. The remaining 9 attributes can then be hard-coded into the snippet, as these rarely change across the location. Similar to the transport asset property set, we have 3 attributes where we've added in here for the asset. SA for the curb type, 1 for the asset instance, and then the start chainage. Again, the snippet assigned to these to do the correct attribute name, and these are passed through to create other attributes, including the asset code and asset label, with the remaining 15 all hard-coded into the snippet. And this includes all the unit class information, as you can see here. So for this curb example, we have manually added 6 fields to generate all 46 attributes required within the BIM object. And the designers or engineers never have to see any of the complex unit class code, because it's all hard-coded in the back end, making things much simpler to apply in the model. So moving on now from snippets, and in this example, I'm going to demonstrate the use of the BIM trimess object apply function by adding in a noise wall. So initially we're going to open it up, and then we're going to basically select the noise wall from our custom library of BIM objects. Then we're going to basically apply a standard set of attributes using the custom global attributes within 12D. So again, a custom list we have developed. So just pick that on from the branches. And now within this, you can see that we've pre-populated much of the project information required with a few prompts in there as well. And then all the location information in there as well. And then if you jump over to tab 2, you can see all the asset information in there. So we've pre-populated a lot of the information we require with all the other data either to be typed, or we've also set up a few drop-downs to add in the same information. So we jump back into just tab 1 here. So we've built drop-downs for the project milestone. So let's say concept design 100% for this example, the state, and also the suitability. So these drop-downs are the same for every project, so it's something sensible you can do for drop-downs. You could also set drop-downs for other attributes, but for this example, we've only done these 3. You can also start typing in a lot of these attributes, including the project name, design company name, etc. But rather than watch me type, we'll just jump straight ahead. So here you can see where we filled out all the project and location attributes, and then jump back to tab 2. We've done all the asset location are all fully populated. So again, quickly, just looking at how we've applied these. So once we basically apply this function, you can see where all the project, location, and asset classifications are all added in. But obviously adding these attributes in this fashion can often be time consuming and can lead to errors. So similar to what we did for the snippet, we can actually concatenate some of these attributes to create new values, including the asset code, asset label, and even the chainage. And here in this example, we're showing the asset label, which is made up of the asset location code, the asset code, and the asset instance. And we can concatenate them three pieces of code together to create the asset label using the attribute manipulator file, which I'm now going to cover. So the attribute manipulator file, so here's an example of using to pull the existing chainage information from an object and push it into the correct name and property set, but also dividing that number by 1,000 to change from meters into kilometers as per the BIM schema. And these attribute manipulator files can be very complex with every code listed you need and beyond, and even some hard-coded in. So in this example, we've hard-coded in the asset data standard for RAMs, or going an extra step, we can add in all the unit class codes for each of the elements and also in all the descriptions as well. So taking that a step further, we can actually use existing attributes generated from other functions within 12D. So in this example, we're actually using the pit type generated from the drainage network editor to create the asset code, in addition to prefixing this with the parent code. So it forms dr.dpit and let's say .sa if it's an SA type pit. And you can do this with many other attributes generated from the drainage network editor and other functions within 12D to much quickly generate that data. And just as an example I showed you previously, so we can concatenate the asset label codes all together. So using the three different codes, we can concatenate into one. So once we have all the data in the model, we can then extract the data to the transport asset register. So using a custom report and parameter file, we can extract all these attributes listed to a CSV file in a standard format. So then we export all these to a CSV file. So all the fields are captured in the same order as they would be in the asset register, with some placeholders added for items to be added in the asset register later, which were not included in the model. We can then simply look at these, select them all, and then paste them directly into the asset register, and they all come in the right place. So you can see all the different headers in here, and there is some placeholders that will populate later, including the asset hierarchy, the location codes, and some of the discipline descriptions and subdiscipline descriptions. So in this example, we only use a noise wall, but we could export all assets out altogether in the same format, as all objects within the model would be classified in the same structure. So once we have all that asset data applied and all the modeling complete, then we can export out all the objects via IFC from 12D, applying all the different property sets. So you can see here we've applied the project, location, and asset, and then brought them all into Navisworks. So all in here. So once we're in here, we can standardize a lot of our processes in Navisworks, including all our clash detection, etc. So thanks very much for your time today. I hope you all learned something, and if you have any questions, please let me know. Thank you very much for your time.